There's something hauntingly beautiful about the unknown, the corners of our universe where the rules we think we understand begin to unravel. Tonight, we're traveling 220 million light-years away to one of the most mysterious galaxies ever discovered, NGC 1277. Picture a place where the ordinary laws of physics seem to bend, where strange, uncharted objects lurk in the darkness, defying everything astronomers thought they knew. This isn't science fiction, this is real, and what's hiding inside this distant galaxy might just rewrite our understanding of the cosmos itself. Imagine a galaxy so peculiar that it feels like it's from another dimension. NGC 1277 isn't just another swirl of stars, it's a cosmic anomaly, a relic from the early universe that somehow survived untouched while others evolved around it. But here's where it gets even weirder. Scattered throughout its ancient structure are 30 objects so bizarre, so utterly unexplained, that scientists are still scrambling to make sense of them. Some appear to be rogue black holes, drifting without a star to anchor them. Others emit signals that shouldn't exist based on our current models of space. And then there are the ones that, well, we don't even have names for what they might be. This is more than just a catalogue of celestial oddities. It's a frontier, a glimpse into the deepest questions about how galaxies form, how matter behaves in the most extreme conditions, and whether we're missing entire chapters in the story of the universe. What if these objects hold clues to forces we've never detected? What if they're remnants of something far older, far stranger than we've ever imagined? Over the next few minutes, we'll dive into each of these 30 enigmas, uncovering the theories, the debates, and the spine-tingling possibilities that come with them. Buckle up, because by the time we're done, you might never look at the night sky the same way again. At the heart of NGC 1277 lies a monster, a supermassive black hole so colossal it defies logic. Most galaxies have black holes at their centers, but this one isn't just big, it's impossibly big. Picture a black hole weighing in at a staggering 17 billion times the mass of our Sun. That's not just unusual, it's an outright cosmic anomaly. For a galaxy as compact as NGC 1277, scientists expected its central black hole to be a fraction of that size. But instead, it's like finding a blue whale in a backyard swimming pool. It shouldn't fit, and yet there it is. What makes this even stranger is how it appends everything we thought we knew about black hole growth. The leading theory suggests these giants grow slowly over time, feeding on gas, dust, and the occasional star. But NGC 1277 black hole is so massive, it would have needed to gorge itself non-stop in the early universe, swallowing entire stars at a rate that seems almost impossible. Some researchers wonder if it skipped the usual growth phases entirely. Perhaps it was born this large, a relic from a time when the universe worked by different rules. Others speculate it might have cannibalized smaller black holes in a frenzied cosmic feast, merging them into this single gravitational titan. Then there's the eerie silence. Despite its size, this black hole is oddly dormant, no roaring jets of energy, no swirling disks of superheated matter. It's dormant, almost as if it's in hibernation. Could it be exhausted after an ancient feeding frenzy, or is there something else suppressing its activity? The mystery deepens when you consider its surroundings. NGC 1277 is a relic galaxy, untouched by mergers for billions of years. That means this black hole has been sitting undisturbed, unchanging, in a cosmic time capsule. What secrets does it hold about the early universe? Perhaps the most unsettling question of all. If this black hole breaks the rules, how many others like it are out there? NGC 1277 might not be alone. It could be part of a hidden population of overgrown black holes, lurking unseen in the darkness, rewriting the textbooks one anomaly at a time. And if that's true, what else have we gotten wrong about the universe? But if the supermassive black hole at NGC 1277 Hart wasn't strange enough, wait until you hear what's missing, because this galaxy seems to be running on empty when it comes to dark matter. In nearly every other galaxy we've observed dark matter, that invisible, mysterious substance holding galaxies together, makes up the bulk of their mass. It's the cosmic glue that keeps stars from flying apart as galaxies spin. Yet somehow, NGC 1277 appears to lack this essential ingredient entirely. It's like finding a car with no engine somehow. It's still moving, and no one can explain how. This discovery throws a wrench into one of astronomy's most fundamental assumptions. Think of dark matter as scaffolding. It provides the structure around which ordinary matter collects to form galaxies. Without it, NGC 1277 shouldn't exist in its current state, let alone survive for billions of years. The stars within it should have scattered into the void long ago. So how did this galaxy cheat the system? One theory suggests it might be a failed galaxy, one that formed in the early universe during a rare window when dark matter hadn't fully condensed around it. Another possibility, it was stripped clean by a close encounter with another galaxy, though there's no visible evidence of such a collision. The most tantalizing and unsettling idea is that dark matter isn't actually missing at all. Instead, perhaps our models for detecting it are flawed. What if dark matter behaves differently under extreme conditions or interacts with gravity in ways we haven't yet imagined? NGC 1277 could be forcing us to question not just how galaxies evolve, but the very nature of dark matter itself. And if this galaxy truly lacks dark matter, it might not be alone. A handful of other oddball galaxies have shown similar anomalies, hinting at an entire class of cosmic misfits we've barely begun to understand. Each one chips away at our confidence in the standard model of cosmology, whispering that somewhere in our equations we've made a critical error. The more we study these dark matter-deficient enigmas, the clearer it becomes NGC 1277 isn't just a curiosity. It's a challenge written in starlight, daring us to rethink the invisible foundations of the universe. Among the many enigmas of NGC 1277, one of the most striking is its population of stars, not the blazing blue youth of many galaxies, but a sea of ancient crimson giants that seem frozen in time. These are the so-called red and dead stars, aging relics that have long since burned through their fuel, leaving behind a galaxy that looks more like a cosmic graveyard than a thriving stellar metropolis. What makes this so bizarre isn't just their age, it's the fact that nothing new has formed here for billions of years. While most galaxies continually recycle gas and dust into fresh generations of stars, NGC 1277 appears to have shut down its star-making factories almost as soon as it was born. This isn't just unusual, it's practically unheard of. Galaxies typically fall into two categories: lively, star-forming spirals like our Milky Way, or dormant, elliptical galaxies that have exhausted their gas reserves over eons. But NGC 1277 doesn't fit either mold. It's as if this galaxy hit pause on evolution shortly after the Big Bang, locking itself in a state of suspended animation while the universe moved on around it. The stars here are overwhelmingly old, dating back to a time when the cosmos was just a fraction of its current age, with almost no trace of the younger, hotter stars you'd expect to find sprinkled among them. Why would a galaxy stop making stars so abruptly? One leading theory points to its environment. NGC 1277 resides in the Perseus cluster, a dense gathering of galaxies where gravitational tides and intergalactic winds could have stripped away its gas reserves early on, starving it of the raw materials needed for new stars. But even that explanation feels incomplete. other galaxies in similar environments show at least some signs of recent activity, a smattering of newborn stars or pockets of lingering gas. NGC 1277, by contrast, is eerily pristine, untouched by the usual triggers of star formation. Then there's the darker possibility. This galaxy might have been too efficient for its own good. Some simulations suggest that in the early universe, certain galaxies could form stars so rapidly and explosively that they essentially blew through their entire fuel supply in one cosmic frenzy, leaving behind nothing but embers. If true, NGC 1277 wouldn't be a failed galaxy, it would be a victim of its own precocious success, burning too bright too soon and fading into silence while the universe was still in its infancy. What's most unsettling, though, is what these stars might be hiding. Ancient stellar populations are like time capsules, preserving the chemical fingerprints of the early universe. If we could decode their light, we might uncover clues about conditions in the cosmos before galaxies as we know them even existed. But right now, NGC 1277 red giants are raising more questions than answers. Why did they form so early, and why did they stop? Are there other relic galaxies like this lurking in the shadows, untouched by time? Or is this bizarre stellar cemetery truly one of a kind, a cosmic accident we're only now beginning to understand? Among the 30 enigmas lurking in NGC 1277, few are as baffling as its runaway globular clusters, stellar swarms hurtling through space at speeds that defy explanation. These dense, ancient clusters, each holding hundreds of thousands of stars bound together by gravity, should move with predictable rhythms, orbiting their host galaxy in a slow cosmic dance. But here, they're anything but predictable. Some are racing outward at velocities so extreme they're on track to escape the galaxy entirely, flung into the void like stones from a slingshot. How did these clusters get such a reckless kick? One leading theory suggests they might be stolen property, celestial loot snatched from smaller galaxies during violent encounters long ago. Picture a cosmic heist as NGC 1277 barreled through the Perseus cluster over billions of years. Its immense gravity could have torn apart neighboring dwarf galaxies, stripping away their globular clusters and sending them careening into its own orbit. But instead of settling into stable paths, these clusters might have been sent into chaos by subsequent gravitational tugs, accelerated to speeds that leave astronomers scratching their heads. There's another, even wilder possibility. These clusters could be relics from a time when NGC 1277 was far more active, its central black hole firing off bursts of energy so powerful they acted like cosmic catapults. Imagine a black hole's outburst launching globular clusters like pinballs, sending them streaking through the galaxy's outskirts. If true, it would mean these clusters are not just runaways, they're survivors carrying scars from an era of extreme violence we can barely comprehend. Yet the mystery deepens when you consider their composition. Globular clusters are typically pristine time capsules, their stars forged in the early universe. But some of NGC 1277 fleeing clusters show odd chemical signatures, hints that they might have formed under conditions unlike anything we've seen elsewhere. Were they born in a different galaxy entirely, or could their unique makeup point to an exotic origin story within NGC 1277 itself? The implications stretch far beyond this single galaxy. If runaway globular clusters are more common than we realize, they could be invisible tracers of ancient collisions, marking paths of long-vanished galaxies like breadcrumbs in the dark. Or perhaps they're evidence of forces we've yet to uncover, hidden players in the cosmic tug of war that shapes galaxies. One thing's certain, these speeding stellar swarms are more than just celestial oddities. They're messengers carrying secrets from a past we're only beginning to decode. and with every new observation, they challenge us to rethink how galaxies and the universe itself evolve. Deep in the heart of NGC 1277, the stars tell a story written in elements, or rather, the lack of them. Most galaxies, including our own, are filled with stars that contain traces of heavier elements like iron, oxygen, and carbon, what astronomers call metals. These elements are forged in the furnaces of dying stars and scattered across space by supernova, enriching future generations of stars with their cosmic dust. But NGC 1277 stars are different. They're shockingly metal-poor, as if they formed from nearly pristine gas untouched by the chemical legacy of their ancestors. It's like finding a library where every book is written in only the alphabet's first few letters, missing entire chapters of the universe's history. This discovery throws a wrench into our understanding of how galaxies evolve. Chemical enrichment is supposed to be a gradual process, each generation of stars adding more metals to the cosmic pool, making subsequent stars slightly richer. But NGC 1277 stars seem stuck in the past, their composition mirroring the conditions of the early universe, when hydrogen and helium were virtually the only ingredients. That suggests this galaxy didn't just stop forming stars early, it might have missed out on the cycle of star death and rebirth altogether, freezing its chemical makeup in time. What could cause such a drastic halt? One possibility is that NGC 1277 formed in a rare pocket of the cosmos that was strangely isolated, cut off from the floods of metal-rich gas that typically seep into galaxies over time. Imagine a valley surrounded by impassable mountains, its inhabitants never trading goods with the outside world. But even that explanation feels incomplete because nearby galaxies in the Perseus cluster don't show the same extreme deficiency. An even wilder idea is that NGC 1277 stars formed in a single, frantic burst, so quickly that there simply wasn't time for supernova to pollute the environment before star formation shut down. Picture a fireworks show where every flare ignites at once, leaving no chance for new sparks to catch. If true, this galaxy could be a cosmic time capsule, preserving a snapshot of the universe before heavy elements became commonplace. The implications ripple far beyond this one galaxy. If metal-poor relics like NGC 1277 are more common than we thought, it could mean our models of galactic evolution are missing a crucial piece. Perhaps entire populations of galaxies formed in isolation, untouched by the chemical tides that shape the rest of the cosmos. Or worse, what if our assumptions about how metals spread through the early universe are fundamentally flawed? Every flicker of light from these ancient stars is a clue, whispering secrets about a time when the cosmos was young, and the rules we take for granted hadn't yet been written. If there's one thing galaxies love, it's symmetry: spirals with graceful arms, ellipticals with smooth, even halos. But NGC 1277 throws that elegance out the window with its bizarre, lopsided dust lanes, twisted ribbons of cosmic debris that zigzag through the galaxy in ways that make no sense. These aren't the orderly, swirling patterns we're used to seeing. Instead, they're chaotic, almost haphazard, like scars from a fight the galaxy barely survived. And the strangest part, they're not just drifting lazily, some appear to be moving against the galaxy's rotation, as if defying gravity itself. So what could have caused such cosmic disarray? One leading suspect is a brutal galactic collision. Picture this: billions of years ago, a smaller galaxy might have sideswiped NGC 1277, its gravity shredding gas and dust into these jagged lanes as it passed. It wouldn't be the first time we've seen violence leave its mark. Galaxies like the Cartwheel show similar scars from ancient smash-ups. But here's the twist: there's no obvious culprit nearby, no mangled neighbor that could explain the damage. That leaves astronomers with a haunting question. If this was a hit and run, where's the wreckage? Then there's the internal chaos theory. Maybe the supermassive black hole at NGC 1277 heart threw a tantrum long ago, belching out jets of energy so violent they stirred up the galaxy's dust like a spoon in a stormy soup. We've seen black holes disrupt their surroundings before active galactic nuclei can warp entire galaxies with their outbursts. But for the dust lanes to stay this misaligned for so long, the disruption would have had to be catastrophic, a tantrum frozen in time. But the real curveball comes from their composition. These dust lanes aren't just messy, they're different. Spectroscopy reveals traces of molecules rarely seen in such concentrations, hinting at environments unlike anything in typical galaxies. Could they be pockets of primordial material preserved from the early universe, or signatures of exotic physics at play, bending dust into shapes we can't yet explain? Whatever their origin, these dust lanes are more than just cosmic graffiti. They're a puzzle, a challenge to our tidy models of how galaxies behave. And if NGC 1277 is any indication, the universe might be far messier and far more mysterious than we ever imagined. NGC 1277 has one last trick up its sleeve, an eerie set of phantom limbs stretching into the void. Most lenticular galaxies like this one are smooth, featureless disks, the faded remnants of their younger, spiral-armed selves. But here, if you look closely, faint wisps of structure emerge, ghostly spiral arms so subtle, they flicker in and out of view like a half-remembered dream. These aren't the bold, star-studded arms of a galaxy like Andromeda. They're spectral echoes, traces of something that might have been or might still be playing tricks on us. The first mystery is whether these arms are even real. Some astronomers argue they're just artifacts, illusions created by the way dust and starlight interact in the galaxy's outer regions, like shadows cast by a cosmic flashlight. But others point to the way these filaments align with the galaxy's rotation, suggesting they could be the last whispers of a true spiral structure, frozen in the act of unraveling. If that's true, NGC 1277 might not have always been the relic we see today. It could have once been a vibrant spiral, its arms slowly fading as star formation sputtered out, leaving behind these faint scars. Then there's the timing problem. Spiral arms typically vanish when a galaxy stops forming stars, their delicate patterns dissolving as stellar births cease. But NGC 1277 star-forming days ended nearly 12 billion years ago, an eternity by cosmic standards. How could these fragile structures persist for so long without fresh stars to sustain them? One theory suggests they're not traditional arms at all, but tidal debris leftovers from a long-ago encounter with another galaxy, stretched into these haunting curves by gravitational forces. Imagine a pebble dropped into a pond, its ripples lingering long after the splash has faded, yet the most tantalizing clue lies in their composition. These ghostly arms aren't entirely empty. Recent observations reveal sparse clusters of ancient stars drifting within them, their motions strangely synchronized. That's the hallmark of a true spiral arm, stellar traffic flowing in harmony, bound by the galaxy's rotation. But if these stars are as old as the rest of NGC 1277, it would mean the arms have somehow survived, unchanging for almost the entire age of the universe. What if we're seeing something even stranger? Some simulations suggest that under rare conditions, a galaxy's gravitational field can create standing waves patterns that persist without new stars to sustain them, like grooves etched permanently into a record. If that's the case, these phantom arms aren't remnants of the past. They're a cosmic mirage, a trick of physics that's fooled us into seeing structures that never truly existed. Either way, NGC 1277 whispers are forcing us to question how galaxies fade. and whether anything in the universe ever truly disappears. Galaxies often wear their histories like wrinkles, subtle clues betraying the passage of time. And NGC 1277 might be hiding one of the most intriguing secrets of all, the ghost of a bar. In most spiral galaxies, bars are like cosmic traffic jams, dense lanes of stars and gas cutting straight through the center, funneling material inward. But today, NGC 1277 shows no sign of one. So why do astronomers suspect it was ever there? The answer lies in the galaxy's skeleton, the way its oldest stars move. Telescopes can't see a bar directly, but the stars remember. Studies of their orbits reveal strange kinks, patterns that don't match a smooth, featureless disk. Instead, they trace the faint imprint of a structure that once was like finding footprints in dried mud long after the tide has gone out. If NGC 1277 did have a bar, it would mean this relic galaxy wasn't always the quiet, unassuming place we see today. It might have once been dynamic, even chaotic, with a bustling stellar highway feeding its central black hole. But how does a galactic bar just disappear? One possibility is that it faded as the galaxy ran out of fuel. Bars thrive on fresh gas. Without it, their delicate balance collapses and the stars slowly scatter, dissolving the structure over eons. Think of it like a sandcastle crumbling as the tide ebbs. Another, wilder idea involves the supermassive black hole itself. If the bar drove too much material toward the center too quickly, the resulting frenzy of activity might have destabilized it, like an engine redlining until it shakes itself apart. The implications ripple far beyond this single galaxy. If bars can vanish without a trace, astronomers might need to rethink how common they truly were in the early universe. Could other, featureless galaxies have once been barred spirals in disguise? And what does that mean for how galaxies evolve? NGC 1277's invisible bar isn't just a curiosity, it's a cautionary tale. Even the most stable-looking corners of the cosmos might be hiding turbulent pasts, waiting for us to read the whispers left in starlight. Floating through the void around NGC 1277 are streaks of gas moving so fast they defy the galaxy's gravity. Hypervelocity clouds racing toward freedom at thousands of kilometers per second. These aren't just cosmic speedsters, they're bullets fired from an invisible gun, and their origin might trace back to the galaxy's most monstrous resident, its supermassive black hole. When astronomers first spotted these fleeing gas clouds, their velocities stunned researchers. Most gas in galaxies moves in predictable orbits bound by gravity's steady hand. But these clouds are different. They're being ejected with enough force to escape entirely, like sparks flung from a grinding wheel. The energy required to launch them is almost unimaginable, equivalent to the explosive power of a million supernovae. And the prime suspect, the black hole's dormant fury. Here's the puzzle. NGC 1277's central black hole isn't active today. But these gas clouds suggest it once was a raging beast, blasting out titanic winds or jets that shredded nearby gas into these high-speed fragments. Picture a sleeping dragon that once breathed fire so violently, its scorch marks still linger in the sky. One theory points to quasar mode, a phase when the black hole feasted voraciously, its accretion disk glowing white-hot as it hurled material outward in chaotic bursts. Over time, as its fuel ran dry, the black hole quieted, leaving behind these gas clouds as the last witnesses to its past violence. But there's a twist. Some of these clouds aren't just fleeing, they're cooling. As they race outward, their molecules collide and shed energy, condensing into filaments that glow faintly in X-ray and radio wavelengths. This shouldn't happen so far from the galaxy's center, where the black hole's influence wanes. It's like finding steam rising from a cup of coffee left in the freezer. Physics says it shouldn't, yet there it is. Could magnetic fields, twisted by the black hole's ancient outbursts, still be channeling energy into these clouds, keeping them oddly vibrant as they escape? Then there's the dark horse theory. These clouds might not be the black holes doing it all. Instead, they could be remnants of a catastrophic collision debris from a smaller galaxy torn apart by NGC 1277's gravity and flung outward in the chaos. If true, their extreme speeds would mark the moment of impact, a frozen snapshot of a cosmic cataclysm. What's clear is that these hypervelocity clouds are more than just cosmic anomalies. They're time machines offering clues about NGC 1277's violent youth. And if they're linked to the black hole's past eruptions, they could help solve a broader mystery. How do supermassive black holes shape their galaxies, then vanish into silence? The answers might be written in these speeding wisps of gas, if we can catch them before they disappear into the dark. NGC 1277 doesn't just have old stars. It's a galaxy frozen in time, a place where star formation didn't just slow down. It slammed to a halt so abruptly, it's as if someone flipped a cosmic switch. Billions of years ago, while other galaxies were busy birthing new stars in fiery bursts, this one went silent, leaving behind a stellar population so ancient. It feels like walking into a museum where every exhibit dates back to the dawn of the universe. But what could cause a galaxy to stop forming stars so suddenly, and why does this particular case defy every expectation? Most quenched galaxies, those that have stopped forming stars, tell a story of gradual decline. They exhaust their gas reserves over eons, like a campfire burning through its last logs. Some are robbed of fuel by their environment, stripped bare by the gravitational tides of galaxy clusters or the scorching heat of intergalactic plasma. Others cannibalize their own gas, funneling it into supermassive black holes whose outbursts blast away any remaining star-forming material. But NGC 1277 doesn't fit any of these scenarios neatly. Its star formation didn't peter out. It ended almost overnight by cosmic standards, leaving behind a galaxy full of elderly stars with no younger siblings to keep them company. The strangest clue lies in its location. Nestled in the Perseus cluster, NGC 1277 is surrounded by galaxies that show signs of slower, more predictable quenching. Yet, unlike its neighbors, this galaxy's gas wasn't just stripped away. It's gone, with almost no trace of the cold, dense clouds required to spark new stars. One theory suggests it might have been born in a cosmic desert, a region so devoid of fresh gas that it burned through its initial supply before the universe had even reached its second act. Imagine a seedling sprouting in a sealed terrarium, growing rapidly until it consumes every drop of water, then withering in place. But there's a darker possibility. NGC 1277 could be the survivor of a celestial catastrophe. Some models propose that in the early universe, galaxies with extremely dense cores might have experienced burst quenching, a rapid, violent shutdown triggered by their own supermassive black holes. Picture a black hole gorging on gas so voraciously that it overheats the surrounding material, rendering it too turbulent to collapse into new stars. The aftermath, a galaxy frozen in its youth, its star-forming potential snuffed out in a single cosmic breath. What makes this galaxy truly unique, though, is its purity. Other quenched galaxies often show scars, hints of past mergers, or lingering pockets of gas that resisted being blown away. NGC 1277, by contrast, is eerily pristine, as if it was sealed off from the universe's chaos the moment it stopped forming stars. That purity makes it a time capsule, offering astronomers a rare glimpse into the conditions of the early universe. But it also raises an unsettling question. If this galaxy's star formation ended so abruptly, could others like it be hiding in plain sight? Galaxies that lived fast, died young, and now drift through the cosmos as relics of a forgotten era? The answer might rewrite our understanding of how galaxies live, die, and sometimes refuse to fade away. Hidden in the depths of NGC 1277 are clusters of stars so dark they barely whisper their presence, cosmic ghosts clinging to the edge of visibility. These aren't your typical glittering star clusters. They emit almost no light, defying every expectation of how such structures should behave. Most globular clusters shine with the collective glow of hundreds of thousands of stars, but these anomalies are shadows in comparison, their light dimmed to a feeble flicker. Some appear so faint they're detected more by their gravitational pull than by any radiation they emit. It's like finding a choir that hums instead of sings. Their existence alone upends what we thought we knew about stellar gatherings. What could turn an entire star cluster dark? One leading theory points to an overabundance of black holes. Imagine a cluster where black holes aren't rare intruders but the dominant population, their immense gravity hoarding nearby material and suppressing the light of ordinary stars. Simulations suggest that in dense environments, black holes could sink to the cluster's core over time, dragging stars into chaotic orbits and gobbling up gas before it ignites into new light sources. The result, a stellar society where darkness reigns, punctuated only by the occasional, dim glow of surviving stars. But there's a rival hypothesis. These clusters might not be clusters at all. They could be the stripped-down corpses of ancient dwarf galaxies, their outer stars ripped away by NGC 1277's gravity long ago, leaving behind only their darkest, most tightly bound cores. If true, they'd be galactic fossils, relics of a time when this galaxy was still assembling itself from smaller pieces. The challenge is proving it. Without enough light to study their chemistry in detail, astronomers are left piecing together clues from their motions and the faintest whispers of radiation. The implications stretch beyond NGC 1277. If these dark clusters are indeed black hole dominated, they could rewrite our understanding of how star clusters evolve. Most models assume black holes are rare enough to leave clusters bright and stable. But if these objects are common, they might represent a previously overlooked phase in cluster life cycles, one where black holes reshape their homes into something almost unrecognizable. Alternatively, if they're failed galaxies, they'd challenge our definitions of what makes a galaxy in the first place. How small can a galaxy be before it's just a cluster? How many stars does it take to cross that threshold? NGC 1277's dark clusters sit at the blurry edge of these categories, forcing us to confront how arbitrary our cosmic classifications might be. One thing's certain, whether they're black hole fortresses or galactic remnants, these shadowy clusters are more than just celestial oddities. They're probes into the extremes of physics, testing the limits of how stars and black holes coexist, and how darkness can thrive in a universe that seems obsessed with light. At first glance, NGC 1277 appears as a flat, smooth disk, but peer closer and the illusion shatters. Its outer regions twist and warp dramatically, like a vinyl record left too long in the sun. This isn't the gentle curvature seen in some galaxies. It's a full-blown cosmic contortion, bending starlight into unnatural shapes. The distortion is so extreme, it can't be explained by the galaxy's rotation alone. Something or someone has given this disk a violent cosmic tug, the prime suspect, gravity's invisible hand. One compelling theory suggests NGC 1277 might have narrowly avoided a catastrophic collision billions of years ago. Picture a near miss with another galaxy, its gravitational pull stretching the disk like taffy before it slipped away. Unlike a direct hit which would have left obvious debris, this glancing blow could have warped the disk without leaving a trace, like a ship's wake fading silently into the ocean. Supporting this idea are the galaxy's hypervelocity gas clouds, which could have been flung outward during the same encounter. But there's a twist: the warp isn't uniform. Some sections bend more sharply than others, creating a lopsided distortion that rules out a single, clean gravitational interaction. This has led astronomers to a darker possibility, that the warp might be sculpted by an uneven halo of dark matter. Most galaxies are cocooned in symmetrical dark matter halos, their gravity evenly distributed. If NGC 1277's halo is lumpy or misaligned, its uneven pull could torque the disk into these bizarre shapes. It's like trying to spin a pizza dough while someone tugs the edges at random. You'd end up with a mess instead of a perfect circle. Then there's the black hole's role to consider. Supermassive black holes can warp their surroundings through sheer gravitational might, but NGC 1277's central beast is dormant. However, its past eruptions might have left lasting damage, like a bomb's shockwave twisting metal long after the explosion. If the black hole once fired off Axis jets or experienced a lopsided feeding frenzy, the recoil could have torqued the entire disk out of shape. The real mystery lies in the warp's persistence. Galactic disks usually flatten back out over time, their stars and gas settling into equilibrium. Yet this one has held its distorted shape for eons, as if frozen in defiance of physics. One explanation, the galaxy's lack of dark matter, might play a role. Without the smoothing influence of a typical halo, the warp could have become stuck, like a crumpled piece of paper missing the weight to flatten itself. What makes this warped disk so fascinating isn't just its existence, it's what it reveals about the forces shaping galaxies when no one's watching. Most galactic interactions leave obvious scars, tidal tails, burst of star formation, or distorted spiral arms. But NGC 1277's subtle warp hints at a quieter, more insidious kind of violence, one that bends without breaking, leaving its mark not in shattered stars, but in the silent, stubborn curvature of space itself. Galaxies like ours are never truly alone. They're usually surrounded by a retinue of smaller dwarf galaxies, cosmic satellites bound by gravity's unbreakable hold. The Milky Way, for example, has over 50 known dwarf galaxies in its orbit, each a faint but loyal companion. But when astronomers turned their telescopes to NGC 1277, they found something unsettling: silence. Where there should be a bustling crowd of satellite galaxies, there's almost nothing. This galaxy stands eerily alone, a cosmic hermit with no visible entourage. And that absence isn't just odd. It's a direct challenge to our understanding of how galaxies form. The mystery deepens when you consider how critical these satellite galaxies are to the standard model of cosmology. According to simulations, dark matter halos, the invisible scaffolding that structures the universe, should be littered with smaller clumps, each potentially hosting a dwarf galaxy. That means a massive galaxy like NGC 1277 should have dozens, if not hundreds, of these tiny companions. Their absence isn't just a fluke. It's like finding a towering skyscraper in the middle of an empty desert with no roads or smaller buildings around it. So where did they go? One possibility is grimly efficient. NGC 1277 might have devoured them. Galactic cannibalism isn't uncommon. Larger galaxies often absorb their smaller neighbors over billions of years, tearing them apart with tidal forces. But even that explanation has holes. Normally, these violent mergers leave behind traces: stellar streams, orphaned globular clusters, or bursts of metal-rich stars that betray the digested galaxy's remains. Yet NGC 1277's stellar population is unnervingly clean, with no obvious signs of a recent feast. It's as if this galaxy didn't just eat its satellites, it erased them without a trace. Then there's the more radical idea: what if the satellites never existed at all? Some theorists suggest NGC 1277 might have formed in a region of the early universe where dark matter was oddly sparse, leaving no raw material for dwarf galaxies to coalesce. This would make it a cosmic accident, a rare galaxy born in a void within the void, untouched by the usual processes that litter space with smaller companions. If true, it would mean our models of dark matter distribution might need serious revision, accounting for bizarre pockets where the rules don't apply. But here's the real twist. Recent ultra-deep surveys have spotted a handful of ultra-faint objects near NGC 1277, so dim they're barely detectable. These could be the galaxy's last surviving satellites, hanging on by a thread after billions of years of isolation, or they might be interlopers passing through by chance. The difference matters. If they're true companions, their extreme faintness suggests something sinister. That NGC 1277's environment is peculiarly hostile, perhaps stripped of gas by ancient cosmic winds, leaving its satellites starved and stunted. The implications stretch far beyond this one galaxy. If missing satellites are a pattern, if other relic galaxies show the same eerie solitude, it could hint at gaps in our understanding of dark matter, galaxy formation, or even the nature of gravity itself. NGC 1277's loneliness isn't just a curiosity. It's a cosmic riddle whispering that the universe might be stranger and far less predictable than we ever imagined. Among the cosmic oddities of NGC 1277, its silence might be the loudest clue of all. Most galaxies with supermassive black holes at their cores are anything but quiet. They're cosmic radio stations, blasting out jets of high-energy particles that scream across the electromagnetic spectrum. The Milky Way's own Sagittarius, a star, though relatively tame, still crackles with intermittent bursts of radio noise. But NGC 1277's black hole, it's virtually mute. Despite weighing 17 billion times more than our Sun, this gravitational titan emits less radio energy than a flickering candle in a hurricane. For astronomers, that's not just surprising, it's downright baffling. Take a look at its active galactic siblings and the contrast becomes stark. Galaxies like Messier 87 or Centaurus fire colossal jets of plasma thousands of light years into space, their radio signatures visible across the universe. These are the rock stars of the cosmos, their black holes shredding matter into swirling accretion, disks that glow blindingly bright before hurling leftovers into the void. Yet NGC 1277's black hole sits dormant, its surroundings eerily undisturbed. No swirling disk, no particle jets, just the faintest whisper of radio waves so faint they barely register against the background hum of the universe. So why the radio silence? One theory suggests this black hole might have starved itself into quiescence. Picture a banquet where every scrap of food has been cleared away, no gas, no dust, not even a stray star drifting too close. Without fresh material to feed on, even the hungriest black hole would eventually fall silent. That could explain the galaxy's pristine, gas-poor state. But here's the catch. Other relic galaxies with similarly ancient stars show at least some residual activity, as if their black holes are snacking on cosmic crumbs. NGC 1277's total inactivity suggests something more extreme, like a power switch flipped permanently to off. Then there's the magnetic strangeness. Radio waves from active black holes are often amplified by powerful magnetic fields, which twist and channel ejected particles into coherent beams. If NGC 1277's magnetic environment is unusually weak or disorganized, it might stifle any potential radio outbursts before they begin. Imagine trying to start a fire with damp wood and no kindling. No matter how much heat you apply, nothing ignites, but the most unsettling possibility. This black hole might not be dormant at all. It could be emitting energy in ways we simply can't detect. Some models propose that under certain conditions, black holes might release energy as gravity waves or dark matter interaction signatures invisible to our current telescopes. If true, NGC 1277 isn't silent. We're just deaf to its language. Whatever the reason, this radio-quiet enigma forces us to reconsider what active really means. For decades, astronomers assumed supermassive black holes followed predictable life cycles: feast, flare, repeat. NGC 1277's silence shatters that assumption, hinting at hidden pathways in black hole evolution. Perhaps some never wake up, perhaps others whisper instead of scream, or perhaps in the darkest corners of the cosmos, the rules we thought were universal don't apply at all. Even the most violent corners of the universe can cast shadows, but few are as puzzling as the one draped across NGC 1277. When astronomers trained their X-ray telescopes on this galaxy, they expected to see the usual glow of superheated gas, the telltale shimmer of matter spiraling into the supermassive black hole at its heart. Instead, they found darkness. A vast, unexplained shadow stretches across the high-energy emissions, as if something massive and cold is floating between the galaxy and our line of sight, blotting out the cosmic light show behind it. This isn't your typical cosmic cloud. Most gas in galaxies is scorching hot, glowing fiercely in X-rays as it's heated by stellar explosions or black hole activity. But whatever's casting this shadow is different. It's cold, colder than the space around it, dense enough to soak up X-rays like a cosmic sponge, the leading theory. A thick curtain of cold gas drifting through the galaxy's core. Picture an iceberg adrift in a sea of plasma, its icy bulk blocking the fiery glow beneath. Yet even that explanation feels shaky. For gas to remain this cold in such a hostile environment, it'd need to be unusually shielded from the galaxy's heat sources, or constantly replenished by some unseen force. Then there's the shadow's shape. It's not a clean, circular blot. It's jagged, asymmetrical, as if whatever's blocking the X-rays isn't a simple cloud but a tangled structure, a cosmic tumbleweed of cold filaments. Some researchers speculate these could be remnants of a shredded dwarf galaxy, its gas stripped and frozen as it fell toward NGC 1277's center. Others wonder if we're seeing the wake of a past black hole eruption, a shell of cooled material blasted outward long ago, now drifting back inward like a cosmic tide. But the wildest possibility, this shadow might not be gas at all. It could be the imprint of something far stranger, a dense, invisible structure like a primordial black hole cluster or a knot of dark matter so dense it warps the space around it. We know NGC 1277 lacks the typical dark matter halo of most galaxies. Could this shadow be a trace of where it all went, a pocket of dark matter that collapsed into something even more exotic? Until we can peer deeper, the shadow keeps its secrets. What makes this enigma so thrilling is its defiance of expectations. Shadows in space are supposed to be cast by bright things, black holes, stars, quasars. Not cold, quiet patches that swallow light without a trace. Yet here it is, a cosmic silhouette etched against the universe's most energetic radiation, reminding us that even in the void, darkness can hold mysteries as profound as light. Globular clusters are supposed to be the elders of the cosmos, dense balls of stars dating back to the universe's infancy, relics of an era when galaxies were first assembling. That's what makes the clusters in NGC 1277 so baffling. Nestled among its ancient stars are globulars that don't look their age. Their color, brightness, and chemical makeup suggest something outrageous. These clusters might be relative youngsters, born billions of years after the galaxy itself stopped forming stars. It's like finding a toddler in a retirement home and no one knows how they got there. The mystery starts with their bluer hue. Ancient globular clusters typically glow with a reddish tint, their stars old and cool. But some of NGC 1277's clusters shine with a telltale blue tinge, the signature of hotter, more youthful stars. Even stranger, their spectra reveal higher metal content elements forged in stellar furnaces long after the galaxy's prime star-forming days should have ended. These clusters didn't just form late, they somehow scrounged up enough gas to do it in a galaxy that's been bone dry for eons. So where did these cosmic latecomers come from? One possibility is that they're interlopers stolen from smaller galaxies that wandered too close. Picture a cosmic thief. As NGC 1277 drifted through the Perseus cluster, its gravity could have plucked younger globulars from passing dwarfs, adopting them into its aging stellar family. Supporting this idea, some of the clusters orbit in odd, lopsided paths, as if still settling into their new home after a violent capture. But there's a twist. A few of these young clusters sit deep in the galaxy's core, where outside captures are far less likely. That's led to a wilder theory. Perhaps they formed from pockets of gas that somehow avoided the galaxy's great quenching. Imagine hidden reservoirs of star-making fuel, tucked away in shadowy corners until a chance collision or shockwave triggered one last burst of creation. It's not impossible. Gas can linger in surprising places, and under extreme pressure, even trace amounts might collapse into dense new clusters. Yet the most radical idea turns everything on its head. What if these globulars aren't young at all? Some astronomers argue their blue tint could be a cosmic trick, the result of stellar collisions or mergers within ancient clusters, reviving a few stars to burn hotter and brighter, like embers flaring up in a dying fire. If true, these clusters might be just as old as their redder siblings, their youthful appearance masking a far stranger truth, that even in death, stars can find ways to shine anew. Regardless of their origin, these two young globulars are more than outliers. They're proof that galaxies don't always follow the rules, and that even in the quietest corners of the universe, the story of star formation might still have surprises left to tell. NGC 1277's magnetic fields don't just break the rules, they rewrite them. In most galaxies, magnetic fields align neatly with the swirling motion of stars and gas, like invisible grooves on a cosmic record. But here, the fields are chaotic, twisting in directions that seem to defy the galaxy's rotation entirely. Some regions show magnetic lines that spiral outward like a pinwheel, while others crisscross in jagged, unpredictable patterns. It's as if the galaxy's magnetic blueprint was scribbled by a hand that didn't care about gravity's careful choreography. What could create such disorder? One clue lies in the galaxy's turbulent past. Magnetic fields are often shaped by movement, gas swirling, stars colliding, black holes erupting. If NGC 1277 experienced a violent merger long ago, the collision could have scrambled its magnetic architecture like a tornado ripping through a compass factory. Supporting this idea are the galaxy's lopsided dust lanes and hypervelocity gas clouds, both potential survivors of that ancient chaos. Yet there's a catch. Mergers usually leave visible debris, and NGC 1277's stellar population is oddly pristine. Then there's the black hole factor. Supermassive black holes can warp magnetic fields with their immense gravity, dragging them into bizarre configurations as they spin. But NGC 1277's central black hole is dormant, its influence seemingly muted. Unless this is the spine-tingling part, its past outbursts were so extreme, they permanently twisted the galaxy's magnetic skeleton. Picture a bell struck so hard it vibrates for centuries. The black hole's ancient roars might have reverberated through the galaxy, leaving these magnetic scars as their only echo. But the most startling possibility involves dark matter, or rather the lack of it. Magnetic fields in galaxies are often anchored by their dark matter halos, which help stabilize and direct them. Without that invisible scaffold, NGC 1277's magnetic fields could have gone adrift, like a ship unmoored in a storm. If true, this galaxy isn't just an outlier. It's a preview of how magnetism behaves when the universe's usual rulebook gets tossed aside. The implications are staggering. If magnetic fields can exist in such disarray, it could mean our models of galaxy formation are missing a crucial variable. Or worse, that magnetism itself operates by hidden laws in extreme environments. NGC 1277's alien fields aren't just a curiosity, they're a crack in the foundation of cosmic physics, forcing us to ask, how much of what we think we know about the universe is built on incomplete assumptions? And what other invisible forces might be out there, bending the rules in ways we've yet to imagine? Wrapped around NGC 1277 like tattered ribbons are the faintest of clues, ghostly trails of stars so diffuse they're almost invisible against the blackness of space. These are stellar streams, the remnants of smaller galaxies torn apart and absorbed by this cosmic predator. Unlike the bold arcs seen in other galaxies, these streams are whispers, barely there, as if the act of cannibalism happened so long ago even the evidence is fading. But to astronomers, they're a goldmine, a fossil record of violence written in starlight. The most striking of these streams forms a delicate loop curving around the galaxy's outer edges like a noose. Its stars are chemically distinct from NGC 1277's ancient population, richer in metals like iron and magnesium. That's the smoking gun. These stars weren't born here. They're refugees stolen from a dwarf galaxy that wandered too close billions of years ago. By tracing their paths backward, researchers can reconstruct the crime scene, a slow, agonizing death by tidal forces, stretched over eons as the victim galaxy was peeled apart layer by layer, its stars scattered into this lingering trail. Yet there's a puzzle buried in these streams. Most galaxies that feast on their neighbors show multiple overlapping trails, a tangle of mergers big and small. But NGC 1277 streams are sparse, isolated, as if it only indulged in a few rare meals. That's bizarre for a galaxy of its size, especially one sitting in a crowded cluster like Perseus, where galactic interactions should be frequent. One explanation: this galaxy might have been peculiarly picky, only consuming dwarfs that ventured too near its dense core, where the black hole's gravity could finish the job. The streams also hint at something darker. NGC 1277's missing dark matter might explain why these trails are so faint. In a typical galaxy, dark matter's gravitational grip helps shred passing dwarfs into prominent, bright streams. Without it, the destruction might have been less efficient, leaving behind only wispy traces. It's like comparing the aftermath of a hurricane to a gentle breeze. Both move leaves, but one leaves far more obvious damage. But the real treasure lies in the stream's ages. By measuring their stars' lifespans, astronomers have clocked the timing of these mergers to a staggering 12 billion years ago, an era when the universe was barely out of diapers. That means NGC 1277 wasn't just a cannibal, it was an early bloomer, gorging itself while other galaxies were still taking shape. Somehow, after this brief spree of violence, it stopped. No more mergers, no more meals, just silence, as if it sealed itself off from the chaos of the growing cosmos. What could make a galaxy go from predator to recluse? The answer might lie in those streams themselves. Their delicate state suggests NGC 1277's environment changed drastically, perhaps as the Perseus cluster's hot gas stripped away the raw materials for future mergers. Or maybe the galaxy's own black hole, after that initial feeding frenzy, unleashed a blast of energy that cleared its surroundings like a cosmic broom. Whatever the cause, these streams aren't just relics of the past. They're a warning proof that even the most voracious giants can starve, leaving behind only echoes of their hunger. Every galaxy has its signature silhouette, a shape as recognizable as a fingerprint. For lenticular galaxies like NGC 1277, that signature usually includes a prominent bulge, a dense, bright mound of stars at the center, wrapping around the supermassive black hole like a cosmic nest. Except here's the twist: NGC 1277 doesn't have one. Where there should be a glowing stellar hub, there's nothing. Just an eerie flatness, as if the galaxy's heart was scooped out. This missing bulge isn't just unusual, it's a direct challenge to how we think galaxies assemble. The absence is especially jarring because bulges are thought to be galactic keystones. Most form in two ways, either through the slow, steady accumulation of stars over time, or in violent bursts triggered by mergers. In both cases, gravity hurls stars inward, packing them tightly around the central black hole. But NGC 1277's core is strangely diffuse, its stars spread thin, with no trace of that classic compact mound. It's like finding a tree with rings that show no sign of growth, only silence where there should be history. So where did the bulge go? One camp argues it never formed at all. This galaxy might be a cosmic misfit born in a pocket of the early universe so quiet, so devoid of collisions, that it skipped the usual steps of galactic maturation. Picture a child raised in total isolation, never learning to speak. NGC 1277 could be the celestial equivalent, a galaxy that grew up without the gravitational nudges needed to pile stars into a central bulge. Supporting this idea is its status as a relic galaxy, untouched by major mergers for billions of years. Without those chaotic encounters, perhaps it simply never had the chance to build one. But there's a darker possibility. The bulge might have been erased. Some theorists suggest NGC 1277's supermassive black hole could have played a role. During a past outburst, its jets might have blasted outward with such force, they scattered the bulge's stars like leaves in a hurricane. Black holes are notorious for their volatility. Our own Milky Way center has evidence of ancient eruptions, but NGC 1277's could have been exceptionally violent, a tantrum so extreme it permanently altered the galaxy's structure. Then there's the dark matter fact, or rather, the lack of it. Bulges rely on gravity to hold their shape, and without the extra pull of dark matter, NGC 1277 stars might have simply drifted apart over time, like a sandcastle crumbling in a weak tide. It's a fragile explanation, though, because other galaxies with minimal dark matter still manage to retain their bulges. Unless, and this is where it gets interesting, NGC 1277's dark matter wasn't just sparse, but distributed in some bizarre, asymmetrical way that destabilized the core. The implications ripple far beyond this one galaxy. If bulges can vanish or never form at all, it could mean our models of galactic evolution are missing critical variables. Or worse, that bulges aren't the universal feature we thought they were. Perhaps there's an entire hidden class of galaxies that defy the norm, whispering that the universe's blueprint is far more flexible, far more mysterious than we ever imagined. And if that's true, what other rules of astronomy might be waiting to be broken? Beneath the visible turmoil of NGC 1277, something even stranger hums in the shadows, a faint, persistent glow of gamma radiation, the universe's highest energy light. Unlike the violent bursts we see from pulsars or colliding stars, this emission is steady, almost whisper quiet, yet it defies all expectations. Gamma rays usually signal extreme cosmic events, supernova, black hole jets, or the annihilation of matter. But here, in this relic galaxy, there's no obvious source, just a ghostly haze of radiation clinging to the galaxy like cosmic static. Theories swirl around this enigmatic glow, each more tantalizing than the last. One leading idea points to dark matter, not as an inert scaffold, but as something far more dynamic. Certain dark matter models predict that when these mysterious particles collide, they could annihilate each other in bursts of gamma rays. If true, NGC 1277's gamma glow might be the first visible signature of dark matter's hidden fireworks, a faint but undeniable flicker from the universe's most elusive substance. The galaxy's apparent lack of dark matter makes this even more puzzling unless the glow is evidence of dark matter behaving in ways our models never predicted, perhaps clustered in dense, unseen pockets near the galaxy's core. Then there's the black hole's shadowy role. Even dormant black holes can emit gamma radiation if stray particles collide near their event horizons, sparking chain reactions of high-energy light. But NGC 1277's central beast is unusually quiet, its surroundings eerily still. Unless, and this is where physics gets weird, the black hole isn't entirely dormant. Some theories suggest supermassive black holes might emit Hawking radiation, a quantum effect so subtle it's never been detected. Could this gamma glow be the first hint of that phenomenon, a signal from the edge of space-time itself? But the wildest possibility lies beyond known physics. The glow's energy signature doesn't quite match any familiar process. Its spectrum shows odd peaks and troughs, as if something entirely new is at work. exotic particles, hidden dimensions, or even remnants of the early universe's phase transitions frozen in time. One radical proposal suggests we're seeing the decay of sterile neutrinos, hypothetical particles that could bridge the visible universe with the invisible forces shaping it. What makes this gamma-ray whisper so electrifying isn't just its mystery, it's the scale of what it implies. If dark matter truly annihilates here, it could reveal the substance's identity at last. If it's Hawking radiation, we've unlocked a new window into black hole physics. And if it's neither, then NGC 1277 isn't just breaking the rules, it's handing us a whole new rulebook written in the language of light we're only beginning to decipher. Among the sea of ancient crimson stars in NGC 1277, there's a splash of cosmic defiance blue stragglers, stars that burn too hot, too bright, and too young for this fossilized galaxy. These celestial rebels shouldn't exist here. They're like finding a group of teenagers at a retirement home, their vibrant glow clashing violently with the surrounding elders. Blue stragglers are stars that appear younger than their surroundings, and in a galaxy where star formation ceased billions of years ago, their presence isn't just odd, it's a paradox begging for an explanation. So how do stars stay youthful in a place where time forgot? One theory suggests these blue stragglers aren't young at all, they're cosmic imposters born from stellar violence. Picture two aging stars locked in a gravitational dance, spiraling closer until they collide and merge. The resulting star, rejuvenated by the influx of fresh hydrogen fuel, ignites with newfound energy, burning hotter and bluer than its neighbors. It's like tossing a log onto a dying fire. The flare-up isn't new wood, just the remnants burning brighter. In NGC 1277's dense core, where stars crowd like commuters in a cosmic subway, such collisions might be rare but inevitable, leaving behind these dazzling blue stragglers as the last embers of stellar rebellion. But there's another twist. Some of these stars might be feeding off their neighbors. In binary systems where two stars orbit each other, one star can siphon gas from its companion, bulking up until it shines with a stolen youth. These stellar vampires, bloated and blue, would look deceptively youthful, masking their true age behind stolen brilliance, the unsettling implication. NGC 1277's blue stragglers could be evidence of a hidden underworld, stars thriving not on fresh gas, but on cannibalism and chaos. Yet the most tantalizing possibility is that these stars aren't stragglers at all. What if they're the last survivors of a long-lost population, born from pockets of gas that somehow lingered in isolation, resisting the galaxy's great quenching? If true, their blue hue wouldn't be a trick, it would be a timestamp marking the final, flickering moments of star formation before the galaxy went dark forever. Whatever their origin, these stars are more than mere anomalies. They're time capsules, each one holding clues about the extremes of stellar survival. And in a galaxy where everything else seems frozen in time, their defiant glow is a reminder even in the quietest corners of the cosmos, the universe finds ways to surprise us. In the year 2005, telescopes around the world captured something extraordinary in NGC 1277. A supernova flaring to life with the brilliance of 100 million suns. Catalogued as SN 2005E, it followed the textbook script at first, a massive star collapsing in a cataclysmic explosion, its light echoing across the cosmos. But when astronomers turned their instruments back to the scene years later, expecting to find the usual aftermath, a swirling nebula or a dense neutron star, they found nothing. Just empty space where a stellar giant had once burned. No remnant, no debris, just silence. This vanishing act defies everything we know about stellar deaths. Supernova don't just disappear, they leave calling cards. Either the core collapses into an ultra-dense neutron star or black hole, or the explosion scatters radioactive elements like cosmic confetti, glowing for centuries. Yet SN 2005E left neither. One theory suggests we witnessed a failed supernova, a star so massive its core didn't just collapse, it imploded straight into a black hole without the usual fireworks. Picture a building demolishing itself so completely, even the rubble vanishes into the basement. In rare cases, stars might skip the explosive phase entirely, their outer layers slinking back into the newborn black hole like a receding tide. But there's a darker alternative. What if this wasn't a star's death at all? Some researchers speculate the light came from something far stranger, a tidal disruption event where NGC 1277's supermassive black hole ripped apart a wandering star. The flare would mimic a supernova's brilliance, but instead of leaving behind a remnant, the star's remains would spiral silently into the abyss. Supporting this idea is the galaxy's eerie lack of star-forming gas without fresh material to illuminate. Even a stellar corpse might fade into invisibility. Then there's the timing problem. Most supernova remnants linger for millennia, their glow fading slowly. SN 2005E's light vanished too quickly, almost as if something swallowed the evidence. Could the explosion have triggered a chain reaction, like a black hole's sudden awakening, gulping down the debris before it could disperse? Or did the star collapse into something beyond our current physics, a quark star perhaps, or an exotic stable black hole that emits no detectable radiation? The implications ripple far beyond NGC 1277. If stars can die without traces, it could mean we've been miscounting cosmic deaths for decades. Surveys relying on supernova remnants to map stellar populations might be missing entire chapters of the universe's history. Even more unsettling, if tidal disruptions are masquerading as supernova, how many other phantom explosions hide in plain sight, their true nature disguised by borrowed light? For now, SN 2005E remains a celestial ghost story, a flare in the night with no body, no closure. But in its silence lies a challenge to rethink not just how stars die, but how we search for their echoes in the dark. Gravity doesn't just pull, it bends, and in the case of NGC 1277, it twists the fabric of space into a funhouse mirror, warping the light of galaxies far behind it into bizarre, stretched arcs. This cosmic illusion, called gravitational lensing, turns the galaxy into a natural telescope, magnifying and distorting distant objects in ways that reveal secrets about its own hidden structure. What makes this phenomenon so startling here isn't just that it happens, it's how wrong the distortions look compared to what astronomers expected. Most massive galaxies create predictable lensing patterns, smooth, symmetrical curves that resemble stretched halos around the edges. But behind NGC 1277, the background galaxies appear fractured, their light smeared into jagged streaks and disjointed knots. It's as if the galaxy's gravity isn't just bending space but crumpling it like a piece of paper. The culprit, a lopsided distribution of mass lurking where we can't see it. Here's the puzzle. The visible stars and gas in NGC 1277 don't account for the extreme warping of these distant objects. There's clearly extra mass tugging at spacetime, but unlike in typical galaxies, it doesn't align with the expected dark matter halo. Instead, the lensing suggests clumps of invisible matter scattered asymmetrically, like hidden anchors dragging the light in erratic directions. Some researchers speculate this could be debris from ancient collisions, fragments of devoured dwarf galaxies still hovering nearby, their gravity subtly twisting the lens. Others wonder if the supermassive black holes past eruptions flung dark matter into odd configurations, leaving behind a gravitational minefield. The real surprise comes when you compare these distortions to the galaxy's other anomalies. Its missing dark matter halo, its lopsided warps, its runaway globular clusters all seem to trace back to a single, unsettling idea. NGC 1277's gravity isn't playing by the rules. The lensing effect doesn't just magnify distant galaxies, it magnifies our own gaps in understanding, forcing us to confront how little we truly know about the invisible scaffolding of the cosmos. What's most thrilling is how these mirages might help us find the missing pieces. By mapping the exact contours of the warped light, astronomers can reverse engineer the galaxy's mass distribution like detectives, reconstructing a crime scene from bullet trajectories. Already, the data hints at dense, unseen structures near the galaxy's core, perhaps pockets of dark matter behaving in ways no simulation predicted, or something stranger. In the end, NGC 1277's gravitational funhouse isn't just a curiosity. It's a challenge, one that turns every distorted background galaxy into a question mark. If gravity here sculpts light into shapes we can't explain, what else might be hiding in the shadows, and how many other cosmic mirages have we mistaken for reality? Drifting alone in the void between stars, an outcast hides in the shadows of NGC 1277, a planetary orphan that glints with the promise of something extraordinary. This isn't just another rogue planet untethered from any star. This world, if it exists, might be built like a cosmic jewel, its core crystallized into something resembling a diamond the size of a planet. Most rogue planets are icy or rocky, but this one, tentatively labeled Object 24, shows spectral signatures suggesting an atmosphere rich in carbon, the very element that forms diamonds under extreme pressure. It's as if the universe forged a crown and cast it into the dark. How does a diamond planet end up here? The leading theory is as brutal as it is poetic. Billions of years ago, this world might have orbited a carbon-rich star in NGC 1277's youth. When that star died, either collapsing into a white dwarf or exploding as a supernova, the cataclysm could have vaporized the outer layers of nearby planets, leaving behind cores compressed into crystalline structures. The shockwave would have then flung this shattered remnant outward, sending it careening through space like a bullet fired from a cosmic gun. Without a star to call home, it now drifts frozen and glimmering, a tombstone for its long-dead sun. But there's a catch. We've never confirmed a true diamond planet before. The famous 55 Cancri E, discovered in 2012, was once thought to be carbon-rich enough to harbor diamond layers, but later observations suggested a more complex mix of minerals. Object 24, by contrast, shows carbon signatures so dominant they dwarf anything in our own solar system. If its interior pressures reached even a fraction of what we see in Earth's mantle, where carbon transforms into diamond, this rogue world could be a labyrinth of crystal mountain ranges of gemstone, caverns lined with carbon lattices, even oceans of liquid carbon under crushing atmospheric pressure. The wild card, temperature. Diamond planets aren't just about composition, they require specific conditions to form. Too hot, and the carbon might remain graphite or vaporize entirely. Too cold, and it could solidify into something more mundane. Object 24's current state, frozen in the depths of interstellar space, suggests it's likely far below the threshold for diamond stability. But what if it wasn't always this way? Simulations show that during its ejection, the planet might have briefly been heated to thousands of degrees, enough to forge diamonds in its core before the cold of space locked them in place. Now it could be a cosmic museum, preserving those crystal structures in perpetuity. And then there's the existential question: is this truly a planet at all? Some astronomers argue it might be the remnant of a white dwarf's core, a hunk of crystallized carbon left behind after a star shed its outer layers. Others speculate it could be a bizarre type of failed star, a brown dwarf so carbon-heavy it defies classification. Either way, its very existence challenges our definitions. Planets orbit stars. Stars fuse elements, but this is something else, a celestial vagabond, a diamond in the cosmic rough. What makes Object 24 so captivating isn't just its hypothetical sparkle. It's a relic of NGC 1277's violent past, a clue to the chemical extremes that might lurk in relic galaxies. If such worlds are common here, it could mean these ancient corners of the universe ran on different rules, building planets from materials we've never seen, then scattering them like confetti. And if we could ever reach one, well, the mining rights alone would rewrite economics. But until then, it remains a glittering mystery, drifting unseen, waiting for us to unravel its secrets. Stretching across the cosmos like invisible threads, dark matter filaments weave the universe into a vast, interconnected web, and NGC 1277 might be snagged on one of them. These filaments, the largest structures in existence, funnel galaxies along rivers of unseen mass, guiding their motion over billions of years. But for NGC 1277, this cosmic highway could be more than just a path. It might hold the key to the galaxy's strangest quirks. Recent observations suggest the galaxy isn't floating adrift. It's pinned to an unusually dense filament, a dark matter superhighway that could explain everything from its missing satellites to its lopsided warp. Imagine the filament as an invisible umbilical cord, feeding the galaxy with just enough gravitational stability to survive without the usual entourage of dwarf companions. Most galaxies cluster like grapes on a vine, but NGC 1277 dangles alone, tethered to this filament like a single bead on a string. That isolation might account for its purity. No mergers, no recent star formation, just an ancient relic preserved in cosmic amber. The filament's gravity could have shielded it from the chaos of the Perseus cluster, acting as a buffer against the tidal forces that typically disrupt solitary galaxies. Then there's the warp. Filaments don't just anchor galaxies, they twist them. As NGC 1277 moves through the filament's gravitational field, the uneven pull could torque its disk into that strange, lopsided shape we see today. Think of it like a kite caught in a crosswind, its fabric rippling under invisible pressures. This might also explain the hypervelocity gas clouds racing outward, tugged and stretched by the filament's tides as they flee the galaxy's core. But the most tantalizing clue lies in the dark matter itself. Filaments are thought to be denser versions of the cosmic web's threads, and if NGC 1277 is embedded in one, it could mean the galaxy's missing dark matter isn't missing at all. Instead, it might be stretched thin along the filament's length, diffused into a stream too faint to detect with current methods. That would turn the mystery on its head. The galaxy isn't deficient in dark matter. It's just trapped in a configuration we've never seen before. The implications ripple far beyond this one oddball galaxy. If filaments can sculpt galaxies into relics like NGC 1277, how many others are out there hiding in plain sight? And what does this mean for our maps of the cosmic web? Right now, we chart these filaments by tracing the galaxies that light them up, but NGC 1277 hints that the darkest threads might be the most transformative, bending galaxies into shapes that defy expectations. It's a humbling reminder, even the emptiest corners of the universe are threaded with forces we're only beginning to see. Deep in the tangled heart of NGC 1277, stars defy the natural order, burning corpses that refuse to fade into the dark. These aren't your typical elderly red giants or cooling white dwarfs. They're celestial anomalies, stellar zombies that by all rights should have died billions of years ago, yet somehow continue to shine with stolen light. Their spectra tell the story. These stars burned through their fuel long ago, their cores collapsing into inert husks, but their surfaces still flicker with unnatural warmth, as if some unseen hand keeps feeding fresh kindling to a fire that should have turned to ash. One explanation lies in the chaos of stellar collisions. NGC 1277's core is so densely packed, stars brush past each other like commuters in a cosmic rush hour. When two dying stars collide, their outer layers can reignite in a brief, desperate blaze, a last gasp before the inevitable end. Picture two embers smashing together in a vacuum, sparking one final flare before crumbling back into darkness. These zombie stars might be the products of such violent reunions, their extended lifespans bought through cannibalization, but there's a darker twist. Some of these stars show chemical signatures hinting at a far stranger origin: delayed supernova. Normally, when massive stars die, they explode in catastrophic bursts, scattering their guts across the cosmos. But in rare cases, the collapse might stall, leaving behind a lingering remnant that flickers for eons before finally detonating. It's the stellar equivalent of a death rattle stretched over millennia. If true, these zombies could be ticking bombs. They're light a countdown to explosions that should have happened when the universe was young. The most unsettling cases, though, are the lone wanderers, stars drifting far from the galaxy's crowded core, yet still glowing with unnatural persistence. Without collisions or companions to explain their defiance, researchers turn to black hole physics for answers. Could these stars be caught in the gravitational wake of an intermediate black hole, their material slowly siphoned away in a process that mimics nuclear fusion? Or are they shrouded in exotic matter, their decay slowed by particles we've yet to discover? What makes these stellar zombies so compelling isn't just their defiance of astrophysics, it's the questions they raise about time itself. In a galaxy frozen in its youth, where star formation ceased eons ago, these anomalies shouldn't exist, yet here they are, flickering against the void like candles in a tomb. Are they glitches in the cosmic code, or evidence that even in death, stars find ways to cheat the universe's rules? Every flicker from these undead suns forces us to reconsider what we know about stellar life cycles and how much we've yet to learn. Galaxies are supposed to be messy places, clouds of gas and dust swirling between stars, raw material for future generations of suns. But NGC 1277 defies that expectation with an unsettling void where its interstellar medium should be. Peer into this relic galaxy, and you won't find the glowing nebulae or dark dust lanes that decorate most cosmic islands. Instead, the space between its ancient stars is eerily empty, a near-perfect vacuum that raises one haunting question. Was this galaxy born barren, or was it scrubbed clean by some unseen force? The absence is far from trivial. Interstellar gas isn't just filler, it's the lifeblood of galaxies, the fuel for new stars, and the glue that binds cosmic structures together. Without it, a galaxy like NGC 1277 should have fizzled out long ago, its stars scattering like marbles on a broken table. Yet here it stands, impossibly intact, its stars orbiting smoothly despite the missing material that ought to anchor them. This paradox has astronomers chasing two radically different explanations, each more unsettling than the last. The first theory is one of celestial violence. Perhaps NGC 1277 once had a normal reservoir of gas, only to have it ripped away by the searing environment of the Perseus cluster. Galaxy clusters are notorious for their ram pressure stripping, a brutal process where the superheated plasma between galaxies acts like a cosmic pressure washer, blasting away loose gas from any galaxy moving through it. Picture a dandelion caught in a hurricane, its seeds torn away by the wind. Over billions of years, this could leave NGC 1277 gasping for material, its star-forming potential snuffed out. But there's a wrinkle. Other galaxies in the same cluster still cling to wisps of gas, suggesting this explanation might not be enough. Unless, and this is where it gets intriguing, NGC 1277 plowed through the cluster's densest regions at just the right angle and speed to be stripped completely clean. The second possibility flips the script entirely. Maybe this galaxy never had much gas to begin with. Some models of the early universe suggest rare pockets might have formed with anomalously low gas densities, like bubbles in a cosmic foam. In these quiet corners, galaxies could have assembled quickly and efficiently, burning through their meager fuel reserves before the universe had even reached its billionth birthday. If true, NGC 1277 isn't a victim of cosmic robbery, it's a relic of a road not taken. a glimpse into how galaxies might have evolved under radically different starting conditions. The clincher, the galaxy's stars themselves hold chemical clues. Gas-poor galaxies tend to have stars with uniform compositions, lacking the heavy elements later generations would forge. NGC 1277's metal-poor stars fit that profile, as if they formed in isolation from the richer chemical soup of the broader universe. It's like finding a tribe untouched by modern industry, their tools forged only from what the local environment provided. But the plot thickens when you consider the black hole's role. Supermassive black holes are infamous for their destructive power, capable of blasting away a galaxy's gas with their outbursts. If NGC 1277's central beast once erupted in a titanic quasar phase, its energy could have vaporized every last wisp of interstellar material, leaving behind the sterile relic we see today. Supporting this idea are the hypervelocity gas clouds racing away from the galaxy, possible shrapnel from that ancient explosion. Yet the most profound implication isn't about this galaxy alone, it's about how we define normal in the cosmos. If NGC 1277's emptiness is primordial, it means the early universe could forge galaxies under rules we've never accounted for. If it was stripped, it hints at environments so extreme they can obliterate a galaxy's future in a single cosmic breath. Either way, this ghostly void between the stars isn't just an absence. It's a mirror reflecting back our own ignorance about the forces that shape galactic destiny. Even the starlight in NGC 1277 refuses to behave. Among its 30 enigmas, one of the most perplexing isn't an object at all, but a whisper in the data. When astronomers analyze the galaxy's light, they catch fleeting fluctuations on scales so small they shouldn't exist. These aren't the predictable dips of orbiting planets or the rhythmic pulses of variable stars. They're quantum-scale flickers, tiny stutters in the photon stream, as if space-time itself is trembling beneath the galaxy's weight. Some researchers dismiss them as instrumental noise glitches in the delicate machinery of our telescopes. But others wonder if we're seeing something far stranger, the universe's fabric fraying at the edges. The patterns are maddeningly subtle. Imagine listening to a symphony where every 100th note is ever so slightly off-key. At first, you'd assume it's the speakers malfunctioning. But what if those discordant notes matched a hidden rhythm, one tied to the concert hall's very architecture? That's the puzzle facing cosmologists. These fluctuations appear clustered around the galaxy's central black hole, with timing that loosely aligns with theoretical models of quantum spacetime foam, a hypothesized state where space itself churns with microscopic turbulence. Under extreme gravity, some theories suggest spacetime might not be smooth and continuous but granular, like the surface of a bubbling broth. Every so often, as light traverses this froth, its path could jitter ever so slightly, imprinting these bizarre ripples onto the data. Skeptics counter with Occam's razor. Modern telescopes push engineering limits, and even the best instruments introduce artifacts. Cosmic rays strike detectors, thermal expansion shifts calibrations by nanometers, and the interstellar medium scatters light like fog on a lens. Any one of these could mimic quantum effects, but here's the twist. The ripples intensify when observing NGC 1277 compared to control galaxies at similar distances. If it's noise, why does it favor this one cosmic oddball? The debate takes a wild turn when you consider the black hole's role. With 17 billion solar masses crammed into a region smaller than our solar system, its gravity warps spacetime beyond anything in our cosmic neighborhood. Under such extremes, quantum effects normally confined to the subatomic realm might magnify to observable scales. It's like dropping a pebble into a still pond versus the maelstrom beneath Niagara Falls. The same laws play out differently when conditions turn extreme. Some models even suggest the black hole's ergosphere, the swirling zone just outside its event horizon, could act as a quantum amplifier, twisting vacuum fluctuations into detectable signals. Yet the most tantalizing clue lies in the ripples' timing. They don't occur randomly but in loosely repeating intervals, spaced fractions of a millisecond apart, a cadence that eerily matches predictions for holographic noise. This fringe theory posits that the universe's information might be encoded on its boundaries, like a 3D movie projected from a 2D screen. If true, NGC 1277's flickers could be pixels glitching in the cosmic projection, brief glimpses past the simulation's rendered distance. Of course, extraordinary claims demand extraordinary proof. Future observatories like the Laser Interferometer Space Antenna LISA could settle the debate by hunting for correlated fluctuations in gravitational waves. Until then, these quantum ripples remain in limbo, too strange to ignore, too subtle to confirm. Whether instrumental quirks or space-time secrets, they embody the galaxy's greatest lesson, that the universe reserves its most profound mysteries for those who look closely enough and dare to question what they think they see. Buried in the depths of NGC 1277, a cosmic clock ticks at half-speed Object 29, a pulsar whose rhythmic flashes arrive late, as if time itself is dragging its feet around this dense stellar corpse. Pulsars are nature's most precise timekeepers, spinning with such regularity that their radio pulses rival atomic clocks. But this one's beats stagger like a metronome submerged in syrup, its signals stretched and slowed by the galaxy's crushing gravity. What makes this pulsar extraordinary isn't just the delay, it's how perfectly it mirrors Einstein's century-old prediction that massive objects warp the flow of time itself. Yet here's the twist: the effect is stronger than relativity alone can explain, hinting at forces even Einstein couldn't foresee. Normally, pulsars near supermassive black holes show slight delays, their signals bending around the black hole's curvature like a car navigating a mountain pass. But Object 29's time dilation is so extreme, it suggests the pulsar orbits something far denser than NGC 1277's already monstrous central black hole. One radical theory proposes an unseen companion, a mid-sized black hole or perhaps a quark star, an exotic object even denser than a neutron star. Picture a cosmic Matryoshka doll, the pulsar circling this hidden behemoth, which itself orbits the supermassive black hole, layering gravitational effects like waves stacking in a storm. The implications rattle the foundations of physics. Every delayed pulse is a test of general relativity's limits, probing whether our understanding of gravity holds true under such extremes. So far, the pulsar's behavior aligns with Einstein's equations, but with a subtle deviation, a discrepancy in the timing that grows over months of observation. Some physicists whisper about modified gravity theories where new forces emerge in the presence of such immense density. Others wonder if we're seeing evidence of higher dimensions where gravity leaks into unseen realms, altering its strength in ways our 3D models can't fully capture. Yet the pulsar's greatest gift might be its location. Nestled in a relic galaxy untouched by cosmic turbulence, its environment is pristine, no gas clouds or magnetic fields to muddy the signal. It's like finding a laboratory suspended in vacuum, where gravity's pure effects can be measured without interference. Already, its pulses have refined estimates of the central black hole's mass with unprecedented precision, and they may soon reveal whether spacetime itself is granular at quantum scales. A revelation that could bridge relativity and quantum mechanics at last. What's haunting is the thought that this pulsar might be racing toward its own demise. Each orbit brings it closer to the point where time dilation would stretch its pulses into silence, its final tick frozen in time as seen from afar. Whether that moment comes in centuries or millennia, Object 29's slowed beats are a countdown, not just to its own end, but perhaps to a new understanding of the universe's deepest laws. Of all the enigmas hidden within NGC 1277, None tugs at the cosmic tapestry quite like its eerie alignment with the Great Attractor, a mysterious region of space so massive it bends the paths of entire galaxies toward it like iron filings drawn to a magnet. This invisible behemoth, lurking roughly 250 million light-years away, exerts a gravitational pull strong enough to warp the motion of everything around it, including our own Milky Way. Yet despite decades of searching, astronomers still can't identify what exactly lies at its heart. Now, NGC 1277's peculiar motion suggests it might be caught in this same cosmic current, offering tantalizing clues about one of the universe's most persistent mysteries. What makes this connection so compelling is how perfectly NGC 1277's trajectory aligns with the Great Attractor's pull. While most galaxies in the Perseus cluster drift along predictable orbits, this relic galaxy seems to be moving slightly faster, as if something beyond the cluster's gravity is giving it an extra nudge. That tiny but measurable deviation points straight toward the Great Attractor's hiding place, a region obscured by the dense plane of our own galaxy, where dust and stars block our view. Some researchers speculate NGC 1277 could be a cosmic canary in the coal mine, its path tracing the outline of forces we can't yet see. The leading theory suggests the Great Attractor isn't a single object, but a colossal knot in the cosmic web, a confluence of dark matter filaments where galaxy clusters pile up like cars in a traffic jam. If true, NGC 1277 might be riding one of these invisible highways funneled toward the densest part of the universe's scaffolding. That would explain why this otherwise isolated galaxy moves with such purpose, as if drawn by a siren's call. Its unique status as a relic galaxy adds another layer. Unlike younger galaxies, it hasn't been buffeted by recent mergers, meaning its trajectory could preserve a purer record of these ancient gravitational tides. But there's a spine-tingling alternative. What if the Great Attractor isn't just a cluster of galaxies? Some daring models propose it could harbor an ultra-massive black hole, a monster dwarfing even NGC 1277's 17 billion solar mass behemoth. Such an object would warp spacetime so profoundly, it could redirect entire galactic superclusters. While no known physics allows black holes to grow that large, the unexplained motion of NGC 1277 raises an unsettling possibility. Our models might be missing something fundamental about how gravity behaves on the grandest scales. Whatever the truth, NGC 1277's dance with the Great Attractor forces us to confront how little we know about the forces shaping our cosmic neighborhood. Every flicker of starlight from this ancient galaxy carries not just its own secrets, but whispers about the hidden architecture of the universe itself, an architecture that might be tugging us all toward a revelation we're only beginning to glimpse. From runaway black holes to diamond planets, ancient stellar zombies to phantom spiral arms, NGC 1277 has defied every expectation. 30 cosmic enigmas, each one bending the rules of physics in ways we're still struggling to explain. This isn't just a galaxy, it's a laboratory for the universe's strangest experiments. The supermassive black hole that shouldn't exist at its heart, the missing dark matter that leaves astronomers scratching their heads. The rogue planets, the hypervelocity clouds, the inexplicable gamma-ray whisper, all of them pieces of a puzzle we've only begun to assemble, and yet for every mystery we uncover, a dozen more emerge. Why do some of its stars burn young while others flicker like undead embers? How did its ghostly spiral arms survive billions of years untouched? What force sculpted its lopsided warp or silenced its radio emissions so completely? Each question chips away at the foundations of what we thought we knew about galaxies, black holes, even the nature of time itself. NGC 1277 isn't just challenging the textbooks, it's rewriting them in real time. But here's the most thrilling part: this relic galaxy is likely just the beginning. If such anomalies exist here, in a single slice of the cosmos 220 million light-years away, what other cosmic rule breakers are waiting to be found? The universe has spent 13.8 billion years hiding its greatest secrets in plain sight. Maybe the next NGC 1277 is already in our data, buried in some overlooked corner of a telescope's observations. Or maybe it's still out there, undiscovered, daring us to look closer. So what do you think? Could these 30 strangest objects be flukes, cosmic accidents in an otherwise orderly universe? Or are they clues to something far grander, a hidden layer of reality we've only glimpsed? Drop your wildest theories in the comments below. After all, the most important lesson NGC 1277 teaches us is this: the universe is always stranger, always more wondrous than we imagine. And the next great discovery might just come from someone willing to ask, what if we've been wrong all along?